All right, so here to start off Unit 2, we're going to get to know the periodic table a little bit better because it's going to have a lot of the information we need as we're starting to study atoms and how they're put together. So we're just going to be filling out page 2 in our packet, really the first page of notes there, learning about some of the different special groups on the periodic table. So first off, what is a group? Well, when I say a group on the periodic table, I'm talking about vertical columns on the periodic table. And another word for those vertical columns are families. And we call these elements in vertical columns groups or families because they share similar properties. Just like you and your group of friends probably have some shared interests, you and your family members have some shared genetics, some shared properties and traits. So these words can help you remember that these are the important groups of elements, and we have special names for some of them that we're going to be kind of going over here in a few moments. Periods, on the other hand, are the horizontal rows of elements on the periodic table, and even though they are technically grouped up into lots of rows and the periodic table has lots of periods in it, those rows don't really have any shared properties, nothing special, no special names. So when we use these words, groups means columns, periods means rows. That's really what it comes down to. So let's get to know the metals a little bit more. And before we get down into what the special groups are, let's talk about some properties of all metals. First off, down at the bottom, when we're notating our periodic table, you will make another note, or you'll mark on there that metals are always to the left of the staircase. But right now you don't see a staircase down there, so it's not as helpful. But it could be worth writing that down here so that we have that reminder. All metals are good conductors of both heat and electricity, and some are better than others, but in general they do conduct electricity and heat very well. They're also malleable, meaning kind of bendable. Technically that means that it's able to be hammered or shaped into thin sheets. Lustrous means they're shiny. They're also ductile, which is often confused with malleable, but ductile means that it's able to be pulled and drawn into fine wire, which is technically a different property. Some things can be malleable, but not ductile, or better at one than the other. And overall, metals tend to be solids at room temperature. They have very high melting points. And of course, the one classic exception is mercury, which is a liquid at room temperature. And it's pretty entertaining to play with, but it's kind of toxic and not good for you. So if you're curious about it, I have a couple of samples of mercury and then some that are very similar that you could see some liquid metals at room temperature. So let me know if you're curious and we can investigate those. Now the special groups of metals are our first group, the alkali metals. And we'll notate this on the periodic table below, but everything in that first column, the first group on the periodic table, is an alkali metal except for hydrogen. And one thing to remember about alkali metals in general is that they are very, very reactive. These are really fun to play with because of how reactive they are. Group 2, right next to them, has a very similar name. It's the alkaline earth metals. The way I remember the difference between these is Group 1 has one special name for its metals. Group 2 has two names, alkaline earth metals. And then groups 3 through 12, kind of that ditch in the middle of the periodic table after the second column and before the other big chunk that sticks up, are what we call transition metals. Now on our non-metal side of that, these are to the right of the staircase, and we'll see that in just a minute. Non-metals tend to not conduct electricity very well. They don't conduct heat or electricity very well. And they can be solids, liquids, or gases at room temperature. So kind of a lot of choices there for our non-metals. I'm not quite sure why it has another little bullet over there at the side. We just really have these two properties for it. Really, when it comes down to it, non-metals have a lot of very different properties outside because there's lots of different special groups there. But our group 17, almost all the way at the end of the periodic table, are our halogens, and then our noble gases, our group 18. Like I said, we'll make a note of where these are on the periodic table in just a moment. Something to remember about our noble gases, and that we'll keep coming back to, is that they are inert. They are non-reactive elements. Then we have our metalloids, and these are going to be the ones that touch the stair step. And metalloids are in between our metals and our nonmetals, and their properties are kind of in between as well. They're blended properties, some metallic properties and some non-metal properties. They do tend to be solids at room temperature, though, and they're what we call semiconductors. There's a special kind of conductivity that they will conduct electricity, but only under certain conditions. But once you meet those conditions, they could be really, really good conductors. So it's just a little bit more complicated stuff here with these metalloids, because they're kind of in between being a metal and a non-metal. Now, we've already started to learn and talk about element symbols on the periodic table, and I definitely saw some people confusing the capitalization of our elements. And it's really important that we do keep that very consistent, because capital C lowercase o is cobalt, capital C uppercase O is carbon monoxide. There's a big difference between these, and even when it comes down to it, this is a compound, that's an element. This, I don't even know what this is over here, because there's no capital F there's no capital E element. So that would be fluorine and something else that obviously isn't right. On the other hand, Fe, lowercase e, is obviously just one iron atom. So we have to be consistent with those symbols. And then you have these diatomic elements listed out below. We're going to circle back around and talk about these over and over and over again. But as we're introducing elements, I always like to point these out. These are the elements that never go anywhere by themselves. Or another way of putting it is that these elements are the ones that can never be alone. I think of, and I don't know why it tends to be more females than males, but there are those females that, oh, I'm going to get something from the lunch line. Will you come with me? Oh, I need to go to the bathroom. Will you come with me? It seems like they can never go anywhere alone. They always need a buddy. And that's the same way with these specific 7 elements, is that if you tried to make H be by itself, it couldn't handle it. Not just an H all by itself. If you do have just a container that's just H in it, and it'll never be a single atom, even if you have a teeny tiny little bit of hydrogen, there's going to be several million atoms in there. Then that H will find another H that's by itself, and they'll form a compound because they're more stable together, even if it is just pure hydrogen. That being said, so H2 is just fine. It's just the single H that isn't. We can also have things like HCl. H and Cl are both diatomics, which means that they can't be alone, but they can be with each other. Just one H and one Cl, they're not alone. So that is a stable compound and a stable form of those diatomics. It's just if we try and force them to be by themselves, pure hydrogen, just oxygen, or just fluorine, that's when they're going to double up. So we'll talk about those more and more with the year, and I just like to introduce them a little bit early. So let's look at that periodic table down there and actually make a note of where these special groups are. You'll notice now that I've taken the exact same groups that we have written up above and I've color-coded them different colors. And so I would encourage you to do the same thing, even if you don't color-code the names, even if you just circle the little dot, the bullet point right next to the group number 1 or 2 and 3 in a specific color, then you'll be able to color in this periodic table the same way. Even if you don't have colors, you can do all of the classification that we need to by circling the elements that I'm going to talk about and maybe labeling them off to the side or numbering them and say, like, this is number 1. Just don't forget to come back up here and say this is number 1, or like A or something, whatever you need in order to make sure you know what is what on the physical periodic table. So the first thing we're actually going to do is draw in that staircase that I kept talking about with our metals, nonmetals, and metalloids. It's important that it's exactly here. So over on that far side of the periodic table, start your line 1 squared down, and then go down and over, making a staircase all the way down. And make sure that that's nice and dark and bold and visible, because that is our dividing line between our metals and our nonmetals. Like we wrote up above, Metals are to the left of the staircase, and non-metals are to the right. Our metalloids, I've made a star symbol in order to make a note of what is a metalloid. And what we said was that those are the ones with a full side touching the staircase. So these specific elements are all metalloids. You'll notice there's one thing that's sharing two sides with the staircase that I did not put a star on. That's aluminum. And aluminum is a metal. It is not a metalloid. It is all pure metal. So we do not star that one. Now I'm using a star here because we are going to come through and color code some of these columns, and those are going to be one of these special names we already saw and a metalloid. So that way I don't have to put multiple colors in each space. I can just make a symbol and then I can add some color around that. So those are our metals, nonmetals, and metalloids. Now let's get our special groups in. Those alkali metals are our first group, our first column on the periodic table. And so I'm coloring all of those in red. Remember, we made a note that adds everything in that first group except for hydrogen, which is at the top. So I'd be coloring in everything underneath that first square. And whatever color you choose, just make sure you go back up to that group 1 where we wrote alkali metals and make a note of that color there. Our second group is alkaline earth metals. Then we've got our transition metals. And then our noble gases and halogens are over in the non-metal area. Halogens are the second to last column, and noble gases are the last column. So that's where we see that we have some non-metals and metalloids, rather, that are also halogens and noble gases. Now, another special group that doesn't really count, they are metals, but we don't use them very much, and just want you to know what they're called. These little groups of elements, or really 2 rows, they're periods, are inner transition metals, and those are down below the periodic table. On every periodic table you'll probably see, but those are part of the periodic table. They do belong in between our alkaline earth metals and the transition metals. And I just want to show you that real quick. This is just a general form of the periodic table you're probably used to seeing. The true form of it looks like this. And the only reason that we pull that inner transition metals down and out of the periodic table is to make things fit better on a piece of paper. Because honestly, we don't use them very much. They just kind of get in the way if they're right front and center in this periodic table, and it makes everything so tiny if I was trying to make that fit on a normal 8.5 and 11 piece of paper. So we just pull them out, pull them to the bottom. That way everything can be bigger and we can just focus on the elements that we do use. So that's our podcast, and hopefully you're ready to start learning about atoms and atomic history next class.